We're now in our second video for Chapter 13. We're going to solve systems of equations using matrices. If you didn't see the first video, 13.1a, it's linked in this description, and it tells you how to find the dimensions of matrices and about the rows and columns. So we can use matrices to solve systems of linear equations. We did that back in Chapter 4 with substitution and elimination. All the operations used on the matrices correspond to the operations with the equations. And since the operations make equivalent matrices, we call them row equivalent operations. And the matrices are said to be row equivalent. So using matrices, we can solve very large systems of equations easily. This is a very structured way of doing the elimination method, but with a calculator or computer. Or in our head, right? So here's the rules for matrix row operations. Each of these row equivalent operations will produce equivalent matrices. We can do interchanging of any two rows of a matrix, multiplying each element of a row by the same non-zero constant, and multiplying each element of a row by a non-zero number and adding the result to another row. Now, when we were doing substitution and elimination to solve for x and y, I don't know if you remember back from Chapter 4, but we would try to find a way to make additive inverses, zero pairs. And what we could do is multiply this equation by a 4 and this one by a negative 3, and that would give us a positive 12x and a negative 12x so that we could eliminate it. Then we could solve for y. Once we have the value of y, we could put it right back into the equation and solve for x. If you don't remember that, there's a link to those videos in this description, okay, to give you a refresher. So when we solve a system of equations with matrices, our goal is to get the matrix in the form where there's just zeros below the main diagonal. And in this matrix, that main diagonal is formed by the A, the E, and the H. See how there's zeros down here below it? And this matrix is said to be in triangular form. So when we've got zeros below the main diagonal, it's in triangular form. Then we put the variables back and complete the solution. So take a look at these two equations. We have a system of equations. Remember, if you see the brace like this in front of the equations, it means we have a system. And we write the matrix using only the coefficients and the constants. So we're going to take out the x's and the y's. So what we end up with is a 2. And there's a 1 there, isn't there? There's an invisible negative 1. And then we have a negative 1 here. We have a 3, a 2, and a 16. So here's our matrix. We do the same calculations with the matrix as we would with the system of equations. Our goal is to put this in triangular form, so we need to get some zeros. So what we can do is, with this first equation, we can multiply it by a 3, and we can multiply this one by a negative 2. That's going to create a 6 and a negative 6, and that's going to get rid of the x value for this red equation. See? We can do mental math and make that first row to the second row. See? We want to change the value that's an A21, A sub 21 to a 0. So we want to change that to a 0 from the 3. See? So what we did was, when we multiplied it by the negative 2 and that by the 3, that became a 6. See the 2? This negative 1 became a negative 3, and this negative 1 became a negative 3. And then when we multiplied the red one by negative 2, we got a negative 6, a negative 4, and a negative 32. When we added them together, we got a 0, a negative 7, and a negative 35. So now this is our new matrix. See? And now, if you can see, we've got the triangle, see, with the main diagonal right here and a 0 below it, the way we want to, see? So this is position A sub 21. It's in the second row, first column. Second row, first column. That's what that 2 and that 1 mean, okay? So now it's in this triangular form, and we can put the variables back in. So that would be a 6x and a minus 3y equals negative 3, right? And this would just be negative 7y equals negative 35. So we take this one, because it's only got one variable, we can solve for that y. Negative 7y equals negative 35. We divide both sides by that negative 7, and we get a positive 5 for our y. Now we can take that 5 and plug it back into our blue first equation and solve for x. And that's going to make that a 15, isn't it? So now we have 6x minus 15 equals negative 3, and we add the 15 to each side of the equation to eliminate this. And we get 6x equals 12. We divide both sides by the 6 coefficient. We get that x is 2. Our solution is a 2 for x and a 5 for y. All right? So now, let's try it with 3 equations. We have a system of 3 equations. We can use matrices. So we write the matrix using only the coefficients and the constants. So we get rid of the x, the y, and the z. And wherever the terms are missing, like right here for the y, we put a 0 as a placeholder. So this is the matrix that we get. We got a 2, a negative 1, a 4, and the negative 3. We've got a 1, a 0 for the y placeholder, a negative 4 and a 5, and we have a 6, a negative 1, because there's an invisible 1 in front there, isn't there? The 2 and the 10, okay? We do the same eliminations and substitutions we would do with equations, as if the variables were there. And we want to interchange the blue and red row, so the number in spot A sub 1, 1 is the red one. So we want this 1 to be up here, so we're just going to interchange them. And you know what? Our rule back here for the matrix row operations says we can interchange any 2 rows of a matrix, right? So that's what we're going to do. We're going to interchange these 2 rows. So now it looks like this. We've got the red one on top and the blue one there. Now we're going to multiply this red row by a negative 2 so that we can create an additive inverse with that 2. And we'll add it to the blue row to make this spot right here. This is A sub 2, 1. Second row, first column. Second row, first column. See? We're going to make that a 0. So when we multiply this by the negative 2, we get a negative 2, we get a 0, we get a 8, and we get a negative 10. Now we add it to this blue row, and we get a 0 for our x. That's where the x would have been, a negative 1, a 12, and a negative 13. Now we have a new matrix. Now we use this for our blue row, see? So we're going to keep our red row and our green row, and this is our new blue row. So we have this new matrix. Now we're going to multiply the red row by a negative 6 and add it to the green row so that we can make this one a 0. So negative 6 times 1 is negative 6. We've got a 0. We've got a positive 24. And we've got a negative 30. And we add it to the green row so that this position, this is A sub 3, 1, third row, first column, see, 3, 1, we're going to make that a 0. Because remember, we're trying to get it in triangular form. We're trying to make everything below that main diagonal zeros, right? So we're trying to get all these to be zeros. So now we're going to add this multiplied by a negative 6 in its new form to this green one. We're going to get a 0 for our x. We have a negative 1, a 26, and a negative 20. Now we have another new matrix. So now we've got our red one that we put down here. We've got our new blue one that we're using now, and now we have a new green one. We want to get that to be a 0, so it's in triangular form. So now we multiply the blue row by a negative 1 and add it to the green one. Negative 1 times 0 is 0. Negative 1 times negative 1 is a positive 1. Negative 1 times 12 is a negative 12. We get a positive 13. We put the green row down here. We add them together. And now we've eliminated this y value. That would have been the y value right here, right? This is the x, the y, the z, and the equal. So now we've got a new green row. We take our red one, our new blue one that we created, and now our new green one, and we now have a triangular form. And if you look right here, this is our main diagonal, and we've got zeros below it, just like we want for it to be in triangular form. All right? So now this is where we're at. We've got zeros below that main diagonal, and now we can put the variables back in and solve the green row for z. Because look, there's no x, there's no y, we're just at z. So we've got this as our red equation with the variables back in it. This is our blue equation with the variables back in it. And this is our green equation with the variables back in it. We just have 14z equals -7. We can divide both sides by that 14 and get that z is equal to a -1/2. Now we can substitute -1/2 for z in the blue row. We put that -1/2 here in place of z, and we do our multiplication, and we get a -6. This is going to eliminate z, and now we can solve for y. We add a 6 to both sides of the equation to create a 0 pair right here, additive inverse, and we get -y equals -7. Divide both sides by, there's an invisible 1 here, isn't there, by that invisible -1. That's right in front of here. And it turns that y into a +7, okay? Now, we know that z is a -1/2 and y is a 7. And we can substitute that -1/2 for z into the red row and solve for x to find out what x is. We put that -1/2 here. So here's our x. X minus 4z equals 5. We do the multiplication. We get a +2. Then we subtract 2 from both sides of the equation to eliminate this additive inverse 0 pair, right? We get x equals 3. So we know our solution is x is 3, y is 7, and z is -1/2. Now, I'm not sure if you think doing it with the variables in it is easier or not, but this is solving a systems of equation using matrices, okay? We just create new matrices and do the elimination and substitution, and we put our variables back in, all right? Our next video is going to be 13.2a. We're going to talk about matrix addition. I'm going to have a link to that one previous video that we just did for chapter 13. And there's going to be a link to 4.2a and 4.2b where we solve systems of equations with substitution and elimination in case you need a review. And I'm going to add this to the Algebra II playlist so that you can just have everything one click away to help you, all right? So have a great day, keep trying, and I'll see you next video. Bye.